Okay, so happy afternoon, everybody. I guess I'm standing between you and some all sorts of other things. This hopefully is going to be a little bit of interactive session. So if you have a question, I think I know at least one person in the audience. But if you have a question or if something is not clear, please don't hesitate to ask. And I'll start with the first question before I even introduce the subject. Can somebody find something funny about the initials that are highlighted here? Anyone here in the audience knows what MANO is? How many people here know what is SDN, NFV? SDN. Okay. So how many people here have been exposed to MANO, VNF onboarding? Okay, so there's going to be hopefully lots of fun for you with many different new topics. As was mentioned, I'm covering for Intel the stack that goes from the MANO down all the way to the server. And what we are witnessing is, if you want cloudification of the telco networks, the telco industry is going from proprietary appliances towards the quote-unquote cloud. You guys think that is a significant event from financial point of view? Any feel how much the telco industry consumes on an annual basis? Any guesses?
Billion?
10 billion?
More.
100 billion?
Billions.
200 billion? 200. 300?
Going once.
Exactly. So, yeah, it's about 300 billion. And if you think that at least 10% of that is hardware, we are looking at some significant phenomena that is actually evolving in front of our eyes. And so in that talk, I'm going to cover some of the fun dynamics of the changes that we are witnessing. I'll start with a very quick SDN NFV, just one slide for those who have not seen that before. And then we'll talk about really the framework that guides our thinking in that space. And two of the, I would say, lead technical issues over there, MANO and VNF. The mix I chose for this is a little bit more technical and very light on business and financial. Folks in the audience, how many folks are technical here? Okay, excellent. So that was good. Okay, so without further ado, we actually believe that in order for this technology or set of technologies that originally were separated, and I'll present them separately and then I'll bring them together, in order for them to be successful and fuel that transition that now you know is really significant on a global basis, we really think that what needs to happen is for those technologies to be pervasive, be everywhere, but that is easier said than done. So today what we are going to discuss is some of the challenges or opportunities, depending whether you're pessimistic or optimistic, that is between us as an industry to achieving those goals. SDN, the classical definition as it was defined originally by the ONF, was all about the separation of control and the data plane. The control in the data plane up to a few years ago, when you would buy a switch or a router, that would be a box. Software and hardware are tied together, inseparable. Interoperability exists for basic features, but you go more sophisticated, it's hard to get it. And that actually puts the network a little bit of a disadvantage as compared with compute and with storage. If we want to talk about the way applications evolve in the data center, we are going to look at application holistically. If we want to think about the idea that there is some central entity, let's call it an orchestrator, and that orchestrator is, with a magic wand, is going to instantiate some virtual machines and some containers someplace and use distributed software or local or NVMe or combination thereof, and I would like to do that with the classical cloud features, then I need a network to do the same. If the network is comprised of boxes that each of them is only aware of its own environment and I don't have central global view, it's going to be hard to do. So if you want the motive of a perfect storm, the idea that we could separate the control in the data plane happened exactly at the time to help us with the notion of cloudification, the notion of NFV. Simply put, NFV, you have on the left, I don't think we have, we do have some laser marker here someplace. On the left, we have those appliances. They are actually present in every network, including in this building, including in every central office that you go. And slowly but surely, they are going to move to the right, where the functionality become some software element. Today, it is predominantly virtual machines, potentially in the future, some container, and we are going to talk about that. And the other important component here that is happened on COTS, on standard servers, white boxes of switches, white boxes of servers, because that contributes to the reduction in the CapEx, therefore makes sense for everybody to take that transition. Okay, so now we introduce the two actors. In this slide, that is taken from the OpenAll community, you could see how the two are coming together. This is one of the use cases, customer premise equipment. So that is the situation where you are at home or you're at your enterprise and you're trying to connect to the internet. What we are seeing here, all of this set of devices, and this is a simplified diagram, are really all sorts of mechanisms like we have to authenticate you, we need to understand the policy associated with your service, what is the billing scheme, what is the security, firewalls, load balancers, maybe need to do something for you on your video, and so on. You have this device, that device, etc. So this is really the control plane. The data plane would go from that enterprise or residential through that point of presence, and then it shoots up into the internet. But we have here few domains, or some of them are actually NFV domains, and some of them are SDN domains. And what you see here is, here's a data center. In the data center, we have OS stands here for OpenStack, because in all of this talk, I'm not going to refer to commercial. I'm actually going to talk specifically about open source, because then there are no limitations. And so you have multiple applications here doing all sorts of pieces of the overall service that I've just described, and that would be deployed in some place. Then if I have this as a regional data center, for example, I need to connect it over some wider network. I may have closer to that customer or enterprise, I may have a point of presence, and there is what I'm going to do some magic. It used to be, this box used to be physical appliance, which really means that every time I want to upgrade, every time I want to change the protocol, every time I want to add a feature, somebody needs to go out there, change it, maybe even replace the box. What this whole model enables us to do is very nicely and dynamically, actually, from that point of presence, I actually control that box remotely. I can change its personality. I could do that actually while it is running. I don't need to even bring it down, and I could actually replace its personality, add features, change the protocol, change the policy. So if going south is cheaper than going north today, no problem, I could do this. The customer can change their preferences and so on and so forth. So this is how they come together. This diagram actually is an attempt to present the next phase in our story, where we are trying to build together the infrastructure, and I'm using the telco mnemonics here. These are the titles that ETSI, which is the European organization that is dealing with standardization of the telco guys, has given that. So that is network function virtualization infrastructure. This is the management and orchestration, and this is actually our actor, the workload, the virtual network function itself. And what we are trying to say here is few things. We are trying to say that you need to take a holistic approach if you are trying to migrate all of those appliances to become software devices. So you need to think about the workload itself, how the orchestrator is going to deal with it. There are some examples here of workloads, and then how it interacts with the server. That may come across as pretty trivial, like who's going to think about them just at the component level. But believe it or not, as we were working in the OpenAll community, which you will see in a few minutes here, that idea actually has not only been the first time it has been introduced, but it actually even got rejection. It took us a few months to convince everybody that the only way we are going to do, this is going to take off, we are going to do that at scale, is if we really link all of those components together. And you will see a specific proposal how to do it and why it adds value. Okay. So the question in 2017, some of you who are old enough may remember that the first white paper that was describing what is NFV came out towards the end of 2012. So that sounds ages ago. And that's why I'm not sure everybody remembers that. But the reality is that we are somewhere in the middle of the road. And so we need to ask ourselves, what are the right things, the most important things that we need to do this year in order to advance that agenda? And in order to guide our thinking and still not dwell on this slide for too long, I wanted to show you kind of the thought process that we are doing, how to frame the question. And I'm going to very quickly move or skip over those that are not exactly technical and pretty much spend most of the time on the technical issues. So like everybody remembers from school, if you don't have a business case, then probably it's not going to fly too much. So the business case here obviously comprises of significant CapEx and OpEx saving, the ideas of flexibility, the ideas of cloud with elasticity, with on demand, with as a service, with multi-vendor. So in other words, instead of a proprietary environment that actually pegs the telco operators to use specific vendors, the idea was, oh, let me open it up. So I'll show you one example of a business case. But that is not really enough. We need to actually have a framework, some sort of evolution that kind of storyline that is going to guide our thinking and actually be used as a mirror that we would look at every year and say, are we on the right track and are we making the expected progress? And similar to the way this was done in early days in the cloud and also in security, we have developed a network maturity model. If you guys go to the Internet Network Builder site, you could download it. I'm very quickly going to show you some examples of how it works, and you will see, and to be honest, when I first looked at that, I was like, oh, it actually does really track the events in the industry pretty much. And then we'll talk about Mano and the VNF data models and wrap it up with new technology frontiers that are going to be in front of us, but we need to remember that there is an extremely important component that pretty much would set the overtone, the undertone, and potentially even dictate the pace here, and these are us, human beings. When you look at the people who are working today in all the major operators, you'll find that they are not exactly fully versed with cloud technology, and that is going to take some time. Networks are built one way, you're trying to change that, that's going to take some time. So that is something to put in the back of our head. Here is a simple example, relates to the use case I just showed you before with the VCPE. Few quick takeaways here. As you might expect, there is a significant reduction in the cost because I don't need to roll out equipment every time. I'm using standard equipment, so I enjoy that, especially when I'm using that or deploying that with a large account. But it is also true that I need to be sensitive to where I deploy it. And what you find is that if you deploy it in that point of presence, in other words, centralized and serving multiple accounts or residential places or enterprises, there's going to be some saving associated with it. And the last example here is that even for the extremely hard case where you have many small accounts, and normally you, like if your grandma needs to deal with new technology, it's a little bit harder. So normally the overhead for support is much harder. Even in that case, there is significant saving because the ability to remote control it reduces significantly the number of technician visits and so on and so forth. The network maturity model, in interest of time, I'll do it really quick. What you see here, starting from no virtualization all the way to Nirvana, where the network is self-aware, completely automatic, no human touch, self-healing, awareness of what services are available in what location, as well as immediately, dynamically being able to deal with surges and dips and troughs, depending on what you have. But in order to understand how we move from one phase to the other, and this slide says that we were somewhere between phase 1 and phase 2, you need to take into account all of those different elements as well. And the claim I'm putting in front of you for this year is that we are going to be somewhere between reaching common information model to starting to get to autoscaling. And I'll introduce those terms in a second. So if you look at, you go read that paper, second phase is all about reaching common information model. The problem today is that even though we are moving from physical appliance to virtual, every vendor is describing the capabilities of the product in a different way. We have few levels, information model and data model. Information model is a little bit more abstract. Data model is really the way you capture it in a programmatic way so that computer programs could actually really read it and take action with it. If we do not have common agreement on how to describe our services, it really means that whoever is trying to deploy that have to work individually and independently with each of the vendors. And every time something changes over there, they need to start integrating that again. And if you have multiple different ways to describe things, it's going to be very hard to control that zoo. The next phase here is really about autoscaling, and that's pretty much describes where the industry is at today. You would like to be in a situation where if you have, and we could stick to that example that I showed you before, but other examples are probably more interesting, like what's called the VEPC, Evolved Packet Core. That is really the heart of the mobile network. That is the set of services that connects the antenna tower that you see as you drive all the way to the Ethernet and all of the other processes that telco needs to run in order to grant you call on your mobile. The problem is that if I have if I didn't really do the first phase of the common information model and got some agreement on how we want to run this, and I could use different vendors' virtual network functions, now imagine that I have some sort of a large network, some level of global, regional, whatever. You have hundreds and thousands of those elements. And it's 5 o'clock, and those who are not as lucky as you are really going home. And so what happens is that we would have a surge in the demand for voice calls, or maybe people want to do video calls or look at the sport event or whatever. Then the question becomes, and that is where we hit the heart of the OpEx and the CapEx saving. So if I have a surge of 20%, what is it that I need to really scale up 20%? In order to answer that question, I first of all need to know where I'm at right now. What's deployed, what's running, what's not running, what is the level of availability? Do I have availability this site? I have availability another site. Does it make more business sense for me to scale up here, scale up there? Do I need to scale up everything end to end, or is it really the heart of the bottleneck just on this piece of my service? Before you get to that visibility, it is very hard to answer those questions. So we thought, maybe naively, maybe not, that as we move to SDN and NFV, complexity is gonna get reduced. Instead of dealing with some proprietary equipment, APIs are going to be standardized, the servers are standard, white box switches and routers, everything should be simpler. The reality is, and this is what this graphic is trying to communicate, that maybe we replaced it with some Lego blocks that are not exactly organized nicely. And there is a little bit of work that is required in order to get them organized. And what I want to suggest, and this is something that we are working on for easily a year and a half, multiple public talks, multiple interactions with any element of the industry, is that we need to achieve some industry agreements. And that if we do not achieve them, then some vendors would have short-term gains because we'll still be in the situation where, oh, you could only deploy my devices or my software, but then longer term, we may all miss the ball. So now let's get a little bit more technical. This model is actually the standard ETSI model. Anyone have seen it before? Just few. So I'll quickly introduce that. At the bottom, we have virtualized infrastructure, compute, network storage, meaning your standard server, white box, or commercial network gear, whatever you have. On top of that, in order to control that, we have the concept of a VIM, and typically, and telco has pretty much standardized when it comes to open source on the use of OpenStack. Still, OpenStack is mainly used in enterprise use cases, but telco is now capturing more than 1/3 of the deployed OpenStack. We have legacy up here, and this is why it is not highlighted. This is the operational support system and the business support system. The business support system would send you the bills that you like to get at the end of the month. The operational support system is actually what used to orchestrate it all. And the way they used to orchestrate it is that if I'm vendor such and such, I would connect into that operational support system using what's called an element management. And that would be typically very proprietary to me. So what you're looking at here is actually coexistence of two models. Since the old model was really physical, static, if you bought a box that had 5 gig of firewall and now you need 6, you are going to buy another box of additional 5. So you have excess capacity and you're stuck with it. The new model supposedly should allow you to scale exactly to where you want to be. And in order to do that, we had to introduce these new components to the right. We have to have an orchestrator that we'll skip the VNF manager for a second, that is really coupled to something like OpenStack. But OpenStack is a cloud management system. So its notion of what it is orchestrating is all about, oh, I'm going to instantiate a virtual machine or container, and then if somebody is asking for another one, I'll go instantiate another one. In other words, it doesn't have a notion of those services like vCPE or VEPC that I was discussing earlier. And in order to kind of marry the two, you need an orchestrator that understands these concepts of these elements, the role they play, and how do I comprise what we call a network service, which is some aggregation of those VNF of those building blocks. But now we have another element over here, and we'll see what different communities were doing with it. And that is the VNF manager. The VNF manager is an element that is designed to manage the life cycle of a virtual network function, which is the workload that we discussed earlier, that is actually, the end of the day, comes mainly today as a virtual machine. So I need to do the standard life cycle management, need to instantiate. I may want to know when it's healthy or not, scale it up, scale it down, and then maybe at the end of the day, remove it from commission, get some logs, get some alerts, etc., etc. So we are really looking at the existence of the old world together with the new world, and as you'll see soon, that would be one source of confusion or different paths the different communities are going to take, and pretty much one of the issues that are slowing down the industry. But there is one important element that I didn't describe, and that is the notion of the modeling, the data model. The basic way to think about all of this system is to say, somebody is asking for a service, and in order for all of this to happen automatically without human beings in the loop, I need this to be described as a data model that a computer program can act on. So I have a model for the service. But in order to do a good match between that model and the infrastructure, I need a corresponding model for the infrastructure. So now the orchestrator is really doing a comparison between one model and another. And Etsy has described an information model over here. And part of the fun is that they have one work group called IFA that describes the information model. They are doing some work on the data model. Remember, the information model are not executable, they are conceptual. And then it is a different standard organization called Oasis that is delivering one spec called Tosca, and then you have the IETF delivering another one called Yang. So we are going to have some fun with all of those components changing. And here are few components for those of you who have not remembered, have not forgot the high school classes on different wars taking place for whatever reason. You will see some interesting dynamics that is unfolding here. 3 communities, OSM, that is affiliated with Etsy. It's the first time Etsy is doing an open source. OpenAll, where I was the vice chair architecture of that group, was an open source community predominantly covering Asia, and that means kind of the larger operator in the world, China Mobile and China Telecom and others. And then recently, earlier this year, they merged with AT&T and created ONUP. There's multiple criteria, and I'm not going to cover, and not going to even make an attempt to cover all of them. But if you are trying to compare and contrast, you need to think about all of those, and you're pretty much familiar with the names here. Obviously, they need to be applied to this set of technology, so it's going to be a little bit different. But if we look at the first one, we'll find that box that was describing, you see the dashed line over here, that was the classical Etsy model. And what they're doing above and beyond that, the resource orchestration is that element that is dealing with the infrastructure and understands the infrastructure and is going to allocate the ample resources in order to cover what we need. On top of that, they are adding design environment, they are adding service orchestrator, which is an element that is aware of the needs of the particular telco service. And then at the bottom, as you could see, there are a few different, call them cloud management environment. Obviously, OpenStack, but VMware is a member of this community as well as of the other community. Recently, they added a plugin to AWS. The idea behind that is that if you are a developer and you want to download the code and you don't want to even set up any infrastructure, you simply go set up a public, on a public IaaS like AWS. You could go instantiate it over there, play with it, develop your software before you want to deploy that. And OpenVim is actually somewhat subset of functionality from OpenStack, and in other areas it has, specifically when it comes to awareness of the infrastructure, it's actually a superset. But this was done by a Telefonica team. It's not something that has its own large community. And now you may recognize some of the elements that I'm showing on the left side. It is actually important to note the physical network functions. Physical network functions really mean this community claims that they can talk to physical appliances that are already in the network. If you recall, we were talking about the fact that the OSS originally used to deal just with those. So part of the dynamics we need to think of is not only how all the other elements evolve, but am I going to continue use yesteryear OSS, or is the OSS itself evolving? And to some players like AT&T, there is no need for OSS anymore. Actually, my Meno or Meno Plus solution is really the new OSS. So there you have another element of the transitions. And at the bottom here, we see 3 SDN controllers that are supported. Need to think about the fact that when any of these communities are telling you that they support all of the above, you do not have a superset of all of the feature of each component. What you clearly have is a subset. So I'm not going to be able to drive all the features of VMware VCD or VMware VIO with software like that, but they're going to pick and choose the features that they can support. The way these communities present themselves, there's going to be all sorts of statistics that is trying to convince you that this is the leading one, how many developers we have, what companies support us, how frequently we refresh and everything like that. The other community was the OpenAll community. That community said, well, we are going to do much more than Meno. We are going to have the Meno, we are going to have VNFs. As I mentioned before, the notion of supporting VNF as part of that scheme was not existing in the industry a year ago. That took us some time and work in order to convince the industry that if you don't have a holistic approach, what's going to happen is that the VNF vendors and the VNF software is not going to be easy to fit into the solution. You didn't work with that community, you didn't check the APIs, you didn't really deal with the onboarding, so you're going to be in trouble. So this is the first community that agreed to take that on. And then it made some claims to support of OSS BSS, didn't really do too much work over there. It definitely was the first community that thought that we shouldn't just take the Etsy model as it is, but we should have SDN as an integral part of the solution. And if you follow the thread regs, you probably see the acronym SD-WAN, Software Defined Wide Area Network, and that is actually the component that is represented by the SDN infrastructure, which enabled that use case that we saw before, that really goes end to end. Before, it was really limited to a single data center. Here is a simplified architecture. You really have the orchestrator that sits on top of something like OpenStack, the new SDN controller, and some orchestrator that is trying to coordinate them. A more detailed architecture, it's here for reference, and I don't think we have time to go into details like that. The community that was created earlier this year, after some significant work in the industry for over a year of agreement between AT&T and China Mobile, and therefore, by definition, just the combination of these two covers a lion's share of all of the mobile users in the world, was built around, let's take AT&T's Ecomp. Ecomp is actually a pretty complete and comprehensive, and you'll see that in the next slide, software that AT&T developed in-house, as well as with the help of third parties, as well as with the use of code from the Open Daylight SDN controller. And they took few of the leading projects that were of interest from OpenAll. So the idea of using the Tosca model, that Tosca model that was created for other reasons is more flexible and is not limited to only network. Not going to get into Tosca versus Yang, but there is definitely a very interesting industry conversation about the merits of each of them and where and why you may want to use each and every one. Right now, we are seeing lots of, I would say, foot movement towards using Tosca as the standard way to describe at least the interfaces to the VNF vendors, and that is extremely important. And we were very pleased to see that the idea of the VNF and working with the VNF vendor was one of the lead things that they wanted to take. You could see some household logos over here representing multiple segments of the industry. Use cases, no different than the use cases of ONAP, but if you dig deeper, you'll find that the use case is more complete. So it is not just the ability to put together something that goes end to end, it is all the other aspects of that. Can I have automation in how I invite the service, in how the service is being instantiated, in my ability to get logs back from that, and so on and so forth. So definitely more ambitious. The first release is going to be in November, but don't hold your breath because we have some challenges here. So this was the original Ecomp architecture. For those of you who are really interested in the subject, there is a 43-page white paper. If you simply go AT&T/Ecomp, you could download. It's open. And you'll see that we have few new elements here that we didn't have before. First of all, there is, for the first time, we are seeing dealing in a holistic way with the design creation. You have to deal with creating of the VNFs. How do I describe, create that model, that what is that VNF supposed to do and what are the requirements it has, what is actually the network service, what VNFs needs to be brought together, and maybe the interaction between them is such I need this bandwidth, I need that QoS, and so on and so forth. So that is an environment that enables me to do something like that. But not only that, we have here the introduction of the concept of policy. And with the concept of policy, I could say, but wait, 5 o'clock, this site is better than the other site, and my hardware in this location is more adaptable to this type of use case, and so on and so forth. So you get to set your policies, you get to set your policies on how you want to behave runtime and so on. Another interesting capability that they have is the DCAE, which is the ability to collect telemetry and analytics and plug on top of that some machine learning or artificial intelligence in order to understand what is happening in my network. All of this has been open source. However, what you get is really the skeleton. AT&T has not shared with the industry the specific policies, the specific catalogs that they have, the specific mechanisms that really control all of that. So what you get is a building block, and if you are another operator that wants to deploy this, you have to apply your own logic on top of that. And then they have this master service orchestration over here that is kind of running the show. So if you put them side by side, this is where the fun begins. Here you have the diagram that we were showing before, and for the careful eye, you'll see that some pieces are missing. And the pieces that are missing are exactly those pieces that have been put in the standard as a compromise between the vendors who didn't want to lose the strongholds in this ecosystem and with the need to go open up everything. So in the AT&T solution or approach, you do not have VMSs, you do not have proprietary VNF managers, it is all integrated. And when you think about that, the reason why you want it integrated is that goes back to that ability to have visibility, ability to have scale up and scale down of all the services in a way that the operator can control that, a way to get the telemetry back and make sense out of that. If I have to deal with everything proprietary, it makes it very hard. So, but now we have two communities that came together. And as the lovely, colorful diagram shows you, some pieces come from here and some pieces come from there. And the reason I say draft on this is that this is still ongoing. So this is not the first time an open source community is dealing with two competing solutions for the same functionality. There are few overlaps over here. As an example, you could see the component called VFC. That really is the China mobile way of doing the orchestration that is much more like the Etsy model. And that is different from what AT&T was doing with their service orchestration and what's called AppC. So the community is going through trying to make that agreement. And so that's going to take some time to settle. For the next gen, just by the way this diagram is laid out, you could imagine that the source of it was AT&T because it's reminds us of the way the Ecomp architecture looks like, but that is one camp's view of what this community is going to do after the first release. This is not something that is yet, discussion is really happening as we speak. So I think we are technically pretty much out of time. So I'll talk for a few more minutes and then open it up for questions. So The other fun stuff is actually on the VNFs, and if you read this, and if you're interested in the subject, SDX Central is definitely the right place to go. So we have, if you didn't sense that from one community with trying to simply put together two elements, we really have a little bit of a Tower of Babel situation over here. There are many things that needs to be discussed, and I can just talk about that for an hour. But what I really want to focus on is some of the problems that are related specifically to the workload, to the applications. Because without them, all of our work on opening up the infrastructure and the orchestration is actually not going to bear fruit. You don't have workload. So we have a problem known as onboarding. You're developing your application. Let's say that you're really doing your best and you decided you want to follow Etsy to the letter, and you want to develop that, say, using Yang from the IETF. Now you go to your favorite or not that favorite operator, and you're trying to convince them to buy your software. Exactly the same way yesterday somebody was trying to go sell their appliance. They now need to do a little bit of more testing. When you were selling a box, you were the person who was responsible for everything around it, and if something goes wrong, your phone is going to be ringing even if it is in the middle of your daughter's birthday. But now we have a different situation. We have shared infrastructure, cloud principles, multiple VNFs could be running on the same piece of infrastructure, and I'm here with my software trying to convince you to actually use it. We need to first of all make sure that it works on your infrastructure, but you chose infrastructure, physical server that comes from this vendor that has this BIOS. You thought we are going to use that software interface. They may be using different hypervisor, different cloud management, and so on and so forth. So the problem for the VNF vendors is that they now need to go like clowns in a circus from one town to the other and repeat the show every time. And every time they change something, because this is telco services, it is regulated, it needs to be certified as well. So you cannot just simply say, oh, I just solved the bug and trust me, I only changed one line of code, everything is wonderful. You potentially have to go through the whole process. But we are not done yet. When we deploy that, we have yet another problem. The other problem is that even within the same vendor, it is not clear that that vendor that has multiple VMs or VNFs like that has tested all of them at the same time on the same server or on that particular server model. So we have multiple challenges, if you want, or opportunities. And so I'm actually going to skip that because of interest of time, but talk a little bit about what we were trying to do in that space. We were trying to make actually the circle really to work in order to ease the pain of for everybody, automate the onboarding process. So if you are looking today at the industry, you will find that if you knock on my door today, it still takes measured in months till that VNF, even if it has everything, is being deployed. And we want to move to the cloud model. So we want to make everything move much faster. There were a few building blocks that we created. I'm going to skip that again in the interest of time. That actually allows the infrastructure to tell the orchestrator what it is capable of and what is available. And then the service needs to tell the infrastructure, here's what I need from you. Because the minute we know what you need, then we could put a nice sandbox around that, and the next one that is going to be deployed on the same platform is not going to step on your toes. So that was work that we were doing, and I'm going to skip forward on that. In these communities of Mano and in standards, what we are driving in order to close the loop is that additional text in gold. So the minute the VNF can say, hey, this is what I need, and the key performance indicators, the KPI is the feedback I need, and I tunnel it through the orchestrator, and the orchestrator tells the server, here is what I need, and the server could provide feedback. Now we created a situation where I have agreement on how I say I need 2 CPUs with so much memory, so much network, and when I know this, I can actually automate the testing. It doesn't solve everything, it simply eases the pain. It also enables us to run multiple servers, multiple services on the same server, which obviously is critical in order to reduce the CapEx. Otherwise, we'll end up in a situation where the cost is too high. So that is an example, and these are things that this is an example of how that worked in OpenAll, and we are not going to talk about that. But just 2 more slides, and then I'll open it up. We cannot ignore the emergence of containers. Last year, it was not that significant. This year, we find more people experimenting with it. Not all the characteristics of containers are really applicable, relevant, or beneficial to everything you need for networking workload. Some of the networking workload are really up and running for a long, long time. They don't necessarily scale as much. You don't need that instantaneous instantiation and everything. Some other use case, like a CPE, where it's close to the user, you just wanted some service, the control plane is lightweight, maybe it makes sense. Another thing is machine learning and the different ways to apply machine learning to the problem. This is a classical loop where you have the software and the hardware at the bottom. You want to collect telemetry. You want to actually marry that to the right orchestration, and then you want to make decision. There is lots of opportunity to innovate over there. Some ideas, and that would be where I stop, is you could use that, and you could find people today in the market that are saying, I'll help you find security breaches, because we obviously moved from a box to some elements of software. There is definitely an interesting conversation to be had, what is more secure, but that is beyond the point. Another important way to help that pain that I was describing with onboarding is to actually use a little bit of intelligence in order to be able to tell, are these 2 VNFs application going to live happily ever after, or are they going to conflict? And maybe I don't need to test as much as I thought I need. I simply would deploy them, and I would get early enough indication, and that would simplify my life. And these are things that we are working on. And obviously, you could use intelligence in order to improve the efficiency of your infrastructure, because at the end of the day, if you remember the beginning, we are talking about doing things at scale. If you want to do things at scale, you better have the ability to do it on demand, scale up, scale down, make sure that your infrastructure asymptotically reaches the level of utilization that the cloud guys could reach. Otherwise, you'll find yourself behind in a position that is not necessarily attainable. So these are the 3 key things that I was intending to cover today. Thanks for your patience and for sticking around longer. And if you have any question, I'm happy to answer that. If you want to be punished with more, that could happen too. Yes.
So you mentioned the whole stack needs these interoperable data models to simplify things. Is it beyond just can you support X and Y, like Mono asking OpenStack, for example, that? Can you give us some examples of what what type of interoperability is needed, and are we doing it? Is OpenStack falling down here by not, looking at these data models? And how they
So
integrate it?
OpenStack, if we start with OpenStack, there are few thoughts that you could have around OpenStack. First of all, as I mentioned before, in OpenStack, you have still, I would say, dominance of the enterprise guys over the telco. That creates a little bit of friction and prioritization of features. What this slide is actually showing is that you have multiple models of what is the way your virtual machine interacts with a vSwitch that obviously is a critical element over here. And so in this particular case, not only we expose the infrastructure, but all of that is actually automated. So what happens is you have two workloads, and one of them, say, wants to use SRIOV, and another one wants to use DPDK, and you have some servers in the infrastructure. Some of them are capable of this, and some of them are capable of that, and here you have some accelerator, and here you have some compression, whatever you have. That whole process, and it needs to be automated in the direction of how the OpenStack infrastructure works with my software, and how, as an example, here this is an interface into Neutron. Because of the way Neutron and Nova are organized, I have to notify Neutron so it could tell Nova what exactly you're doing, especially for SRIOV, because you are bypassing, and so it needs to happen. So this, as an example, is fully automated. Where we are trying to get now Mano, and the two dominant communities right now, ONAP and OSM, are using OpenStack different northbound API. They are using AT&T and China Mobile, both were using HIT, while OSM is directly hitting on Nova, because then it could set the filters that could automate something like that. So you have multiple places where you need to agree. This particular example is only a little bit more work, but the key aspect, I believe, is to get the VNF vendors off the hook. The problem for these guys, so there is another element that I didn't touch on here for shortage of time, because I had to introduce concepts and things like that. But different communities, and again, these two communities, OpenAll was about in full agreement that we want to use Tosca, and not only to describe what the VNF is comprised of and what its requirement, etc., but internally, because what you do with the Tosca YAML, as an example, you create workflow and everything is automated, and actually you know that the workflow that has been created, if you trust your parser, represents exactly what you wanted. So that is a very powerful position to be in. You have older implementation, and AT&T has some of that, and China Mobile has some of that, where people are using BEPL, and that requires a little bit of human intervention. So that, for the existing state of the industry, is actually good, because some people still have humans in the loop, but the industry is going to zero human touch, and that's going to change. And then if you compare that to OSM, OSM has 100% Yang internally. However, Rift, as one of the players in that community, has publicly demonstrated in an event that we sponsored in May this year that they can take VNFs that are Tosca, and nothing is lost on translation between Tosca to Yang. So what we want to drive, and we think that eventually we are going to get there, is that for the VNF vendors, you have to design your stuff to one definition. And we don't care, actually, if different orchestration environments are going to translate it to something different. That's not the point. The point is that if we are going to ask the VNF vendors, and the number that they share with us is that anywhere between 30 to 50% of their energy goes to this onboarding. So in other words, you're really slowing down the industry that way. And that is the reason we are trying to solve that. So you have interoperability in many, many places. You have the TM Forum working on other aspects that are important. You have business issues. You need to think when you are deploying end-to-end, as an example, like that use case that I showed. In many cases, it's going to be multiple operators. How do these operators interact with each other? What would be the business arrangement? It is not like you pick up the phone and you call Joe and you say, hey, you know, today, no, it all has to be automatic. So these are mechanisms that needs to be put in place. So there are many, many other moving parts that are needed here, and we are focusing on those that we think, and this is where a maturity model like that helps, where we think it really affects what happens on the ground right now, how we could help make that happen. Because like any other technology, you have the classical hype cycle and everything. You need to make sure it moves and it produces. Any other question? Yes.
Well, this talk was more, I guess, NFV telecom focused, but some of my question had to do with, I guess, with open networking in general, and like we're having, like part of open networking and moving about open, like disaggregating, like networking devices, and having sort of open, like a more open source stack of software running on it. So, and then some of these efforts here, like DVDK, is also like more on the server side, trying to improve the networking, like on commodity hardware. So, is there? I'm wondering, is there going to be more convergence on like at least, say, in the hardware side?
So
like say in the silicon sense?
as you pointed out, there are multiple things here that are happening, and so the network technologies with SDN and all the relevant technologies, white boxes, is applicable not only to telco. It's applicable. We are working with the different cloud providers in order to do that. Even the NFV is not exactly just for telco. It's the idea that if you as an enterprise want to have, a firewall that you want to attach to this line of business, you will be using similar technologies. You simply are not going to have the regulation. You are not necessarily going to have that stringent SLA that comes with it. So it's going to be different. But all of those mechanisms of automation that enable you to do that is going to be common. And that's the logic also behind using something like OpenStack. So we are technically out of time. So
last question. You have gone from nano to nano all the way, and in the Intel, previously there was a presentation on sample VNF.
Yeah.
And what is the correlation of sample VNF? Because it's released in OPNFV, it's not released in ONAP. How do you view that?
Yeah, no, that's a good question. I know you had on the agenda before something we called NSB, and we are using sample VNFs because one of the important requests that we got from lead customers is to help, because those VNFs are software, and you cannot necessarily get a commercial vendor to kind of do open kimono and tell you exactly what they're using in there. But at the same time, the operators would like to have the ability to have some idea. If I want to deploy 5 gig firewall, is that taking 1/4 of a server, or is that taking 1/10 of a server? And then they have the ability also to compare and contrast. So we are creating completely non-commercial example software that has the basic functionality, but it is cannot be a product, so it doesn't compete with anyone. but at the same time, it enables us to develop all the tools and the test harness around it, and then it goes to places like OpenAll, and the industry comes together over there, and you could test your commercial, and the operators could also do capacity planning with it. So these are complementary pieces, and normally when the talk is going in different direction, and that would not be on the agenda, I would talk a little bit about NSB, but it was covered here today, so there was no need.
Thanks.
Yeah.
Yeah, and to add to that, thank you Ori, for talking. I'm not going to that. The dinner is served in the cafeteria, guys. So thank you for attending. Thanks, Ori, for the talk.
Sure.
You can go to the cafeteria because lightning talks are scheduled to be starting in 15-20 minutes. You should have ample time to eat your dinner. Lines are dying down. That's a good news. But I think you guys need to go to the cafeteria. Thanks again.